dive into Mind Syrup, your sweet spot for science and technology enlightenment.
Imagine, for a moment, the possibility of a real-life Star Trek shield. How might that look? Envision a force field, almost invisible, yet powerful enough to protect a spacecraft from the harshest conditions of the cosmos. This is the concept of a Star Trek shield. It's an integral part of the series, providing defense against alien attacks, meteor showers, and the unforgiving vacuum of space. But what if we were to tell you that there might be 3 possible ways to bring this science fiction staple to life? Over the course of this video, we will be discussing the potential of plasma shields, electrostatic shields, and magnetic shields, each with their unique properties, and each offering a fascinating glimpse into the future of space travel protection. Are these shields purely science fiction, or could they become a reality? Let's delve into this intriguing question. First off, let's consider plasma shields. Picture a wall of superheated gas. Sounds like something out of a sci-fi movie, right? But let's delve into the science behind it. Plasma is the 4th state of matter, comprising of charged particles, ions, and free electrons. It's found in many places in the universe, including the sun and other stars. Now, if we could create a wall of this superheated charged gas, theoretically, it could act as a shield, absorbing or deflecting incoming objects or energy. The concept of a plasma shield hinges on this principle. Imagine a spacecraft surrounded by a layer of plasma. Any incoming projectiles or energy beams would have to pass through this superheated electrically charged gas. Depending on the intensity and frequency of the incoming energy, the plasma shield could either absorb it, convert it into heat, or deflect it away. But how would we go about creating such a shield? Well, we'd need to heat a gas to extremely high temperatures, to the point where the atoms break down into ions and electrons, forming a plasma. This process requires a tremendous amount of energy. Moreover, maintaining a plasma shield would be another mammoth task. Plasma by nature tends to disperse quickly, so you'd need a way to contain it. This is where magnetic fields come into play, as they can confine the plasma and maintain the shield. However, creating and managing these magnetic fields would be a significant challenge in itself. Additionally, we'd also need to consider the effects of the plasma shield on the spacecraft itself. The heat and radiation from the plasma could potentially damage the craft or interfere with its systems. So, while the idea of a plasma shield is fascinating, there are many hurdles to overcome. It's a bit like trying to hold on to a handful of mist. It's elusive, volatile, and requires a tremendous amount of control. So while plasma shields might be a bit out of reach right now, science is always advancing. Who knows what we might achieve in the future? Next, we have electrostatic shields, a fascinating concept that involves manipulating electric charges. It's a bit like the static electricity that makes your hair stand on end, but on a far grander scale. So let's break this down. Electrostatic shields work on the principle of electrostatic repulsion. You know, like when you try to push 2 magnets together and they resist each other? That's because they have the same charge, and like charges repel each other. An electrostatic shield, theoretically, would harness this principle to create a protective barrier. Imagine this. You're aboard the Starship Enterprise, and a barrage of photon torpedoes is headed your way. The electrostatic shield, charged to a high voltage, repels these torpedoes, causing them to veer off course and protect the ship. Essentially, it's an invisible force field that deflects incoming threats. But how would we go about creating such a shield? Well, it's not as simple as rubbing a balloon on your hair. The shield would need to be created using an array of high-voltage electrodes, which would generate an electric field. This field would then interact with the electric charge on the incoming threat, causing it to be deflected. But it's not all smooth sailing. There are significant challenges to overcome. For one, creating a stable high-voltage electric field in the vacuum of space is no easy feat. Additionally, the shield would need to be able to withstand the intense heat generated by the deflected threats. And then there's the issue of power. Generating and maintaining such a high voltage would require an enormous amount of energy. We're talking about a level of power that far surpasses what we're currently capable of producing. Yet, despite these challenges, the potential of electrostatic shields is tantalizing. They could revolutionize space travel, providing unprecedented protection for spacecraft. And who knows, maybe one day they could even be used to protect cities or entire planets. Creating an electrostatic shield in real life presents its own unique challenges, but the potential applications are undeniably exciting. Finally, let's explore magnetic shields. Imagine harnessing the invisible forces that move compass needles, the silent energy that guides our planet through the cosmos. We're peeling back the curtain on a force that's both familiar and mysterious, and it's all about magnetism. The concept of a magnetic shield is quite straightforward. At its core, it's about creating a magnetic field strong enough to deflect harmful particles and radiation. Picture Earth's own magnetic field, the invisible shield that protects us from the harmful particles and radiation of space. Now imagine replicating that on a smaller scale, say around a starship. The science behind magnetic shields is rooted in electromagnetism. When an electric current runs through a wire, it generates a magnetic field. If we coil that wire around a core, the magnetic field intensifies. In theory, if we could generate a strong enough magnetic field around a starship, we could deflect harmful particles and radiation, much like Earth's magnetic field does for us. But making this a reality isn't a walk in the park. The challenge lies in generating a magnetic field strong enough and stable enough to serve as a shield. Not to mention, the power requirements would be astronomical. We're talking about a field that needs to be maintained continuously over vast distances and in the harsh conditions of space. That's no small feat. Yet the potential applications are exciting. Magnetic shields could protect astronauts from harmful space radiation during long-duration missions. They could safeguard delicate electronics aboard spacecraft. They could even serve as a defense mechanism against weapons in a more Star Trek-like scenario. But as always, science and technology are a work in progress. We're not quite ready to shout, "Shields up," just yet. The road to creating a real-life magnetic shield is filled with challenges, both known and unknown. But if we can crack this code, the rewards could be immense. The science behind magnetic shields is complex, but the potential to create a real-life version is tantalizing. So, could we really create a Star Trek shield in real life? Let's take a moment to recap our explorations. We've delved into the fiery realm of plasma shields, harnessing the power of heat. We've investigated the intriguing world of electrostatic shields, creating a force field of charge. Then we've journeyed into the invisible forces of magnetic shields. Each of these concepts has presented us with a fascinating glimpse into the possibilities of creating a real-life Star Trek shield. However, the current state of science and technology informs us that we're still in the early stages of understanding and implementing these concepts. The intricate interplay of heat, charge, and magnetic forces is complex, and we've just scratched the surface. While we may not have Star Trek shields just yet, the journey of exploring these concepts is a thrilling adventure in itself. And who knows, one day we might just hear the command, "Shields up," in reality.
Cherish knowledge, give a thumbs up, hit subscribe, explore science and tech.